Solving quadratic equations using the quadratic formula. In the last couple of videos, we saw how we could solve quadratic equations by extracting the square roots and by factoring. Now we're going to use something called the quadratic formula or the quadratic equation. This is a formula that can be used to solve any quadratic equation, and is often useful for dealing with quadratic equations that are difficult to solve by other means. And when we say solving, we mean finding the real zero values of the equation. That is, the x values that will cause the left side of the equation to equal 0. If we look again at the standard form of a quadratic equation, we have ax squared plus bx plus c is equal to 0. Again, a is equal to the leading coefficient of the x squared term, b is the leading coefficient of the x term, and c is the constant. If you use the leading coefficients and the constant, you can plug them into the following formula. Negative b plus or minus the square root of b squared minus 4 times ac over 2a. This is how you'll most often see the formula written. I prefer to write it in a slightly different version below, because for each equation you're going to have two values, and because both terms in the numerator have the same denominator, you can divide it up this way: minus b over 2a plus or minus the square root of b squared minus 4 times ac over 2a. Let's use this on a problem that we previously solved by factoring. We have x squared minus 9. In a previous section, we solved this by factoring it out to x plus 3 times x minus 3. And we can see from that the values of x that satisfy this equation are plus 3 and negative 3. However, to illustrate a point, let's solve it using the quadratic equation and see if we get the same answer. For this quadratic equation, the value of a is 1, since 1 is a leading coefficient of the x squared term. We don't have an x term here, so the value of b would be 0, and the value of c is negative 9. So let's plug these values in and see what we get. For the first term, if we plug in the value of b, that is 0. Now, we know that this is going to make that entire term 0, but for the sake of completeness, let's evaluate the 2a in the denominator. So we have 2 times a, in this case a is 1. Then we have plus or minus the second term. Since the value of b again is 0, we would say 0 squared minus 4 times a being equal to 1, times c, which is negative 9. So if we drop down below, we see that the first term is 0. And then if we multiply negative 4 times 1 times negative 9, we get a positive 36 under the radical, because we're multiplying a negative times a negative. Again, the denominator here is 2 times a is equal to 1, so the denominator here is 2. So if we take the square root of 36, we get 6 for the numerator, and we still have 2 for the denominator. 6 divided by 2 is 3, and since we have a plus or minus 3, the solution to this problem would be positive 3 or negative 3, which agrees with what we see above. That was a pretty straightforward problem. But let's use a quadratic formula again to solve a more complicated problem that we've seen in the past. And that is negative 2x squared plus 5x plus 3 is equal to 0. Here the values of a, b, and c are negative 2, 5, and 3 respectively. So using this formula again, the value of b is 5, so we plug that into the first term, and then we divide that by 2 times a. A in this case is negative 2, so this term becomes 5 over 4, because the negative in the formula cancels out with the negative from the denominator. Then we have plus or minus the square root of b squared, again b is equal to 5, minus 4 times a being equal to negative 2, times c, which is equal to 3. Then again we have that over 2 times a. So simplifying this out a bit, we have 5 over 4 plus or minus the square root of 25 plus 24, since negative 4 times negative 2 times 3 is equal to 24, over negative 4. 25 plus 24 is equal to 49, and we know the square root of 49 is 7. So the second term becomes negative 7 over 4. So for the two answers we expect, we get 5 over 4 plus negative 7 over 4, or 5 over 4 minus a negative 7 over 4. That gives us negative 1/2, or 3 respectively. And that's it for the quadratic formula. We've now seen a way that we can solve any quadratic equation when other means fail us, or we're having a difficult time, or we just need to check our work. Let's break here. When we come back, we'll talk a little bit more about factoring polynomials